Welcome to This Explainer. Today, we're diving right into something absolutely fascinating, the hidden science of light. We're going to unpack how we actually see, where color truly comes from, and, that invisible energy that's literally bouncing all around us every single second of the day. Let's get right into it.
So let me ask you something. Have you ever walked into a pitch-black room and immediately slammed your shin right into a chair? Yeah, ouch, right? We've all been there. But the thing is, in the dark, that chair is completely invisible to us. And that's because, without light to bounce off that chair and into your eyes are effectively useless. Let's break down exactly why that is.
Section 1. How we actually see.
Okay, so here's a kind of surprising baseline fact. The everyday objects around you, they don't actually make their own light. Unless they glow like the sun or a light bulb, everything else is just a reflection. It's a pretty straightforward four-step sequence. First, a source emits light rays. Second, those rays travel in perfectly straight lines until they hit something. Third, the light bounces or reflects off objects in the room. And finally, step 4, some of that reflected light actually enters your eyes, sending a message to your brain to create the picture you see. So if you take away step 1, the source, literally nothing else happens. No bouncing, no image.
Now, what's really wild about this is how long it took us to figure it out. Back in ancient Greece, people actually believed our eyes worked kind of like flashlights, literally shooting out beams to scan objects. Can you imagine? It wasn't until about 1,000 years ago that a brilliant scholar named Ibn al-Haytham proved that totally wrong. He laid out the truth we just talked about. Light has to come from the outside, bounce off objects, and then go into our eyes. I mean, think about it. If our eyes actually shot beams of light, we'd be able to see perfectly in that pitch-black room with the chair.
Section 2. Unlocking the rainbow.
Right, so now that we know how light gets into our eyes, let's look at the light itself. Because that bright sunlight streaming through your window, it's not actually just blank, plain white light. To see what I mean, you just need a really simple scientific tool, a prism. A prism is just a clear, triangular piece of glass or plastic. And what it does is separate white light into a whole band of colors. When that white light enters the angled glass, it bends. But here's the secret sauce. Each hidden color inside that white light actually bends by a slightly different amount. Red light bends the least, and violet light bends the most, so they all just fan out.
And when those colors spread out like that, they form this absolutely beautiful band of separated colors, which we call a spectrum. Basically, that plain white light was hiding every color you can imagine, just neatly folded up together, until the prism came along and pulled them apart. Now, those separated colors always appear in a very specific order: red, orange, yellow, green, blue, indigo, and violet. If you want a classic, super easy way to anchor this in your memory, just use the acronym ROY-G-BIV. Next time you need to remember the spectrum, just think of our very colorful friend, Roy.
And this brilliantly illustrates exactly how a rainbow works out in nature. Obviously, there isn't some giant glass triangle floating in the sky. Instead, tiny water droplets just hanging in the air after a rainstorm act like millions of tiny individual prisms. Sunlight enters those droplets, separates into that Roy-G-BIV spectrum, and bounces right back toward your eyes. Which, by the way, is exactly why you only ever see a rainbow when the sun is directly behind you.
Section 3. The secret of color.
Okay, so if we know white light holds all the colors, why do everyday objects look the way they do? Like, if white light hits a red apple, why does the apple only look red? To get this, we just need to quickly look at absorption. To absorb literally means to take in. So when an object absorbs light, it's essentially soaking up that specific light energy instead of letting it bounce off.
Let's bring it back to that apple. When the full spectrum of white light hits it, the surface of that apple acts like a giant sponge for almost everything. It absorbs the orange, the yellow, the green, the blue, the indigo, and the violet light. It literally drinks all of those colors right up. The only color it rejects, the only one it reflects and bounces back into your eyes, is red. So, the absolutely crucial point here is what we can call the golden rule of color. The color you see equals the color the object reflects. The colors you don't see equal the colors the object absorbs. Take a green leaf, for example. It reflects green and soaks up the rest. It's just a beautifully simple formula for how we experience our entire visual world.
Section 4. Light equals energy.
Now here's where we connect all this color physics to its real-world impact. See, light isn't just visual data for our eyeballs. Fundamentally, it's moving energy. It has the actual power to make things happen. Just look at this massive number, 150 million. That's how many kilometers the sun's light energy has to travel through the freezing vacuum of space just to reach us here on Earth. And when it finally arrives, it does a lot more than just give us a pretty view. That energy literally warms our entire planet, and it completely powers plants through photosynthesis. Light is raw power.
Think about this in your everyday life. On a blistering hot sunny day in the middle of summer, are you reaching for a white shirt or a black shirt? Well, let's use our golden rule. A white shirt looks white because it reflects all the colors. And because of that, it's reflecting all that solar light energy away from your body, keeping you way cooler. A black shirt, on the flip side, absorbs all the colors. It reflects almost nothing. So all that absorbed light energy is converted directly into heat. And that is exactly why dark objects feel so drastically warmer in the sun compared to light ones.
Section 5. Bending light at home. Before we wrap up, I want to give you a fun, actionable little backyard magic trick you can do to see all this physics in action for yourself. It is incredibly accessible. You honestly probably have all this stuff within 20 feet of you right now. You just need a strong flashlight, a clear, smooth glass of water, a plain white piece of paper, a garden hose or a simple spray bottle, and, of course, a sunny day.
First up, let's check out refraction, or bending light, right in your kitchen. Fill your glass about 3/4 of the way up with water. Then, in a darkened room, just shine your flashlight right through the side of the glass at an angle, pointing it onto the white paper. You'll literally watch the light bend, and you might even catch the faint colors of the spectrum as the light exits the water. Pretty cool, right? And for part 2, take that garden hose outside on a sunny day. Put it on a fine mist setting, make sure the sun is directly behind your back, and just spray it right into the air. You will create a literal, brilliant rainbow hovering right there in your backyard, using those tiny water droplets as thousands of little prisms.
So I'll leave you with this question. The next time you look at a simple red apple sitting on your counter, or a giant rainbow stretching across the sky, are you just going to see simple colors? Or will you see the invisible, energetic journey of light, bouncing, bending, and transferring power right before your very eyes? Thanks so much for joining me on this explainer today. Keep observing, stay curious, and keep wondering about the incredible science hidden right in plain sight.